Hi, have you come across situations where you felt the responses generated by your LLM-based chat agent, whether it is ChatGPT or Gemini, were more general and not specific to your unique business scenario? If so, our today's video is for you. Today we are discussing another very important topic in generative AI space, which is Retrieval-Augmented Generation, or RAG for short. RAG lets AI agents ingest user data and synthesize it with their domain-specific knowledge bases to give users high quality and more relevant responses. For example, we can build a RAG model with all the user manuals of our products, so our customer chat agent can find a more tailored solution using those manuals to our clients' problems. Next, how can we build a RAG model? Or what are the important stages of building a RAG? There are four essential stages of building a RAG model. First one is chunking. This is also called as data loading and splitting. This involves importing all necessary documents or information for the RAG model, dividing these large documents into smaller, manageable segments to optimize processing. Second stage is embedding. Here we are transform each chunk into a vector format using an embedding model, making it machine readable. For example, we can transform a chunk into an array of 1536 values between 0 and 1, representing the meaning of the text. Generally, this is done with LLMs because they make embeddings more accurate. To store these embedded vectors, you will need a vector database like PG Vector or Amazon Bedrock Knowledge Bases. Third stage is indexing. Once the vector database is finalized, you can set up an index to store your vectors to facilitate efficient search and retrieval. Fourth stage is querying. This is where we convert the user input query into a vector using the same embedding model that we used in the second stage above, and then find the most similar matches from our previously embedded vector database using some sort of similarity metric such as Euclidean distance or cosine similarity, etc. The final step of re-ranking is an optional step and should be performed only if you want to fine-tune and enhance your current RAG model. This is computationally expensive, but it can improve the ordering of results to deliver more relevant responses for subsequent user inputs. Now we will discuss in more detail on how to choose a vector database for the second stage of embedding and storing vectors. There are a variety of choices for vector databases. For instance, if you are looking for solutions built on top of open source databases, PG Vector and libsql are great choices. For standalone open source, Chroma is excellent. If you are looking for a hosted cloud service, Pinecone is a great choice. Next, if you are looking for a solution hosted by an existing cloud provider, Cloudflare Vectorize and Amazon Bedrock Knowledge Bases are excellent choices. However, Sam Bhagwat's recommendation for vector databases in his book of Principles of Building AI Agents is as follows. If you are already using Postgres in your current tech stack, PG Vector is a convenient solution. If you are starting a fresh project, Pinecone is a default choice with a nice UI. If your cloud provider has a managed vector database, go with that, such as the Amazon Bedrock Knowledge Bases in the AWS cloud. Now is the action time. Do you know why we embedded our chunks into an array of 1536 values between 0 and 1? I want you to research about it and submit your answer as a comment to this video. Finally, These are the important references I used in creating this video, and I highly recommend everyone to refer them. In a future video, I will actually walk you through building a RAG model using some coding and cloud examples. If you like this content, please like, share and subscribe for similar content in the future. See you again in another video. Until then, elevate.